All right, question 3. An ice cream dessert is in the shape of a hemisphere. So a hemisphere is just half a sphere. And the dessert has a radius of 5 centimetres. The top and base of the dessert are covered with chocolate. The total surface area in square metres is... So this is actually when you've got to include the base as well. So I think what happens is the base is a circle. So there you go. You could find the area of a circle, if you like. And the top part, say the dome part, which is also covered in chocolate, is half a hemisphere. So what I believe has happened is that probably people forgot to have the base part in there. So if you look up your formula sheets, which we will do, I've got that here. So I've got a hemisphere. I'm going to take the sphere up there. So we've got a sphere. So really we're talking about surface area. So this is the formula. This is a formula for a sphere. So a hemisphere, if you've got half of that bit, so that's like 2 pi r squared, because 4. But that's only giving this part 2 pi r squared. If you've got the base as well, that's another thing. So for really the total surface area of a hemisphere is actually, and I think there's a few formulas sheets that might have this already, is actually 3 pi r squared, okay? So if we do that on our calculator, 3 times pi times the radius, 5 squared. Awesome, let's go. In the triangle ABC, the point D lies on the line AC as shown. The length BC is equal to BD. So what you want to do is you want to start looking at if these two are the same, that's an isosceles triangle. And just to help you out, indicate that you know therefore these two angles are going to equal each other. Even if you haven't worked out what they are yet, you can still know that they're equal. Okay, and which one of the following statements is true? So let's have a look. Angle BAD, so it's when they talk about BAD, they talk about, it's meaning the angle in the middle. So I'll call that BAD is this angle here, okay, is equal to ADB. So ADB is this one here. Okay, are they equal? No, which one of the statements is true? So let's have a look. Let's keep going. We can't really tell. We can't be for sure. Well, you can sort of see they're not, but let's keep going. We'll come back to that. Angle ADB, so that was the purple one, is equal to angle BDC. So it's talking about BDC is this one here. Okay, now they are definitely not equal, are they? No, because what happens is you actually know this one, these two here make up 180, yeah? And so generally, so yeah, we're going to say that's definitely not true. Okay, the sum, let's have a look at the next one. So the sum of the angle ACB and ADB. So let's have a look at this one. ACB, so ACB, so this angle here, and the angle ADB, the purple one here, is equal to 180. Now, I am going to agree with that because what happens is this angle, we already know that, don't we? This angle is the same as that one there, isn't it? So you can definitely see that's true. So I'm not even going to worry. I now know that is true. And I can see that 100%. Can you see how it helped me? Because I'd already marked that these two angles were equal with a little symbol. So yes, they do add up to 180. Yeah? So I'm going to go with that. That's the answer. If I want, so you can go around, these other ones didn't look right. They don't look equal. And then so when you come back, just come back and check these, and hopefully if you've got time. So what I want you to do in the exam, you've got your answer, you're happy with that, move on. Come back and check the ones that you didn't do, and hopefully you prove them to be wrong as well, then you're correct. You can't. Okay, all cities in China are in the same time zone. All right, so you've got Wuhan and Chengdu are both cities of China. On one day in January, the sun set in Wuhan or whatever at 5:50 p.m. Assuming that 15 degrees of longitude equates to 1 hour, the time the sun set in Chengdu on the same day is. So we want the difference in the longitude, okay? Now, the longitude values are the east and west ones, yeah? So you can see the east and the west there. So if you look, Wuhan is 114 east and Chengdu or whatever is 104 east. So there's a difference of 10, yeah? 10 degrees. So if 15 is 1 hour, so if you go 10 out of 15, you've got 2/3 of an hour, yeah? So what's 2/3 of an hour is 40 minutes, yeah? You're happy with that? So that's 40 minutes difference in the sun setting. Now, remember, the more east you are, the more east, the first you get the sun, yeah? Sorry, I don't know how to say that, sorry. But you get the sun first. So if you look at Wuhan, is going to get the sun set first. If it gets sunrise first, it gets sunset first, yeah? So Wahoo, or whatever it is 40 minutes ahead. Now, so they have the sunset, so then 40 minutes later is going to be the Chengdu. So what's 40 minutes onto 5:50? 6:30. So 6:30, that's right. Okay, so four identical circles with radius r are drawn inside a square as shown in the diagram below. The circle has been shaded, the circles enclose an area that has been shaded in the diagram. The area of the shaded, can be found using. So what you've got to look at is with these, when you have these circles inside another one, because I think they had another exam question where it looked like this, yeah? It was a similar thing. There was something as well where they asked you for the area in between there or something like that. Anyway, so what we've got 4 circles here. When you get any of these circle questions, what I want you to do is start using the radius straight away. So look at this. You can go, that would be the radius. So connect them all together with the radius. So can you see if I do this? All right, so what I've done is I have created a little square in here like that. Can you see? And would you agree that that's 2R, 2R, 2R and 2R? Okay, now if you look here, you've got this bit here. This is like a quarter of the circle, is it not? Yeah? So a quarter of a circle, you've got there, there, there and there. Okay? So this is a quarter of a circle, the quarter, a quarter, and a quarter. So if you think, if I added all those quarters up, I'd have a full circle. So if I had all this area here. So wouldn't you think, so that would be those bits. So wouldn't the area of the black bit, the shaded region, So wooden area of the shaded. What about if I found the area of the full square, so the full square, and then if I cut out the area of those 4/4, wouldn't I be left with just the bit in the middle? Is that true? Yeah. So I'm going to say that the area is the square minus the area of the 4/4. So 4/4 makes a full circle, doesn't it? Yeah? So I can just say that's pi r squared, because that's the area of a circle, isn't it? Pi r squared. And then how do you find the area of a square? You just times it by each other, don't you? So really it's like 2r times 2r. If you do 2r times 2r, you get 4r squared, yeah, minus pi r squared. Is that an answer? B. Sweet. And that is the answer. All right, so each year begins on the 1st of January. The location that begins the year first is. So remember, further east gets sunrise first. So if you're we're looking at the east, which is like the longitude values. So we're going to look at all these longitude values. So who's got the biggest east value? Port Moresby. So they're going to begin the year first. E. Done. Okay, a cake in the shape of a rectangular prison is shown in the diagram below. The cake is cut into half to make 2 equal proportions. The cut is made along the diagonal, so you can see here, along the diagonal, as represented on the dotted line. The total surface area in square meters of one proportion of the cake. So what you've got to think about is we've got to just draw what we've actually got. We actually only have this piece of cake like that, okay? And so, oh, sorry, it's a bit. You've got these and you've got that side coming down like that. Sorry, it's a bit messy. All right, so you think you really should break up the sides. So think about what you've got. You'll have, if I call this the top, yeah, you've got the bottom of that in the same shape. Would you agree? Yeah? So I'm calling that the top and the bottom of this triangular piece. So we're doing all the sides. I'm going to write all the sides to find the surface area. So this, I've got 2 of them, because this is the top and the bottom. Okay, and if you can, while you're there, you might put the dimensions if we can work it out. So we know this is 6 along here, and we know this is 8 along there, okay? And this is a rectangle, so you've got a right angle triangle. So you've got, when you do finding the area of that shape, you might put the formula. So an area is half base times height, and you've got to remember we have 2 of them. So you're going to do 2 of them, okay? So in the end, this bit will be a half times 6 times 8 times 2, which is going to be, whatever it worked that, what's that, 56? No, 48? Yeah? All right, so that bit's 48. So we've done the top and the bottom. Now, if you think about it, we've just got one of these sides down the end because it's a triangular piece, isn't it? Yeah? So I'll call this the end. So I've got this end piece, which would be a 6 by 6. So that bit is 36. Okay? I've got this side bit along here. So that's along there. So that's a rectangle, which I've got a 6 by 8. So 6 by 8, that is also 48. Okay, now you've got to remember that the side down over here, there's this long rectangle side down the side of the diagonal, yeah? So it has, so really you've got this rectangle that is the height of it, which is, 6 and 6, and then you've got the cut. It's got a cut. This is the cut line. So along here, the cut line, that bit there. So that is I'll just call it the diagonal. And we know that this is 6. So really to get the area of this one, I need 6 times that diagonal. Yeah? So we need to work out that diagonal. So I'm going to use that top triangle where I've got the diagonal line, I've got along the 6, and then I've got along the, say along there, that's 8. So I can use Pythag. So this is this diagonal that I want. So I can use Pythagoras if I want. So you can say d squared equals 6 squared plus 8 squared. You can do solve, comma, d. And let's find out what the length of the diagonal is. So that's 10. So it'll be 6 by 10 in the end. So which is 60. And so to get the total surface area, we have to add all these numbers up. So we've got 48 plus 36. So let's just do that. 48 plus 36 plus 48 plus 60. And I get 192. Yeah? So total 192. C. Shot put is an athletics field event in which competitors throw a heavy spherical ball, a shot, as far as they can. The size of the shot for men and the shot for women is different. The diameter for men is 1.25 larger than the shot for women. Okay, so the ratio of the surface area of women's to the so they want to do women, careful here, they want to do women to men. Okay, so they want to do, first of all, we've been given the length ratio. So what you want to do, if men is 1.5, you can say, well, it's like 1 to 1.25. Now this is not, this is doing decimal. So if you do that in your calculator, just go 1 divided by 1.25, and hopefully if you do that in your calc, you'll get a fraction. So when you do that, you get 4 on 5. So really we could say the length ratio, because we don't really put decimals in a length ratio, is 4 to 5. Okay, so this is when you'll get this when your calc is on exact values. Okay, so then what they want though is they want the surface area ratio. So any area ratio, doesn't matter if it's surface area or not, will be the length ratio squared. So 4 squared is 16 and 5 squared is 25. Is 25. So we get the answer E. An 80-metre high lookout tower stands in the centre of the town. 2 landmarks on the same horizontal plane are visible from the top of the lookout tower. The direct distance from the top of the lookout tower to landmark A is 170. So what they've done there is they're giving you, it's like a line of vision there. So when they say 170 and they've got the tower, they also said the tower was 80 metres. So in there, you are creating what is actually that thing is a right angle triangle. So what we might do, and it'll make it a little bit easier. So you've got point A on the ground, you've got point B on the ground. I'm going to call down here, I'll call it the bottom of the tower, yeah? And then I've got top of the tower. So I'm calling it TT and BT. So when they gave you that piece of blue information, maybe it might be easier to separate it out. So if you look, if I call this the top of the tower, bottom of the tower, and I've gone out to point A here, and they said this is 170. So I can see that right angle triangle in that situation. So horizontal plane means that you're along the ground. So that's along the ground, and then the tower goes straight up. Yeah. So you can see that in there. So then when the next one here, when they say the direct distance from the lookout tower to tower B, point B, so you've got another right angle triangle there. So if you were just to draw that a little bit more simple, so you've got the bottom of the tower, top of the tower, and then out to point B. So they gave us 234 is the direct line. Now just remember, we also know that the tower is 80. So they're both 80 there, yeah? The tower's 80 high. So we've got two triangles there with a little bit of information. Now the question goes on. Now when they get down to here and they say the bearing of landmark A. So when we get this, start getting this bearing question, we're going to do a new diagram. When we do bearings, it's like we're looking down on a map. So we're not looking up at the 3D, we're just doing like flat, a point on a map. So let's go from here, because they say the bearing of landmark B from landmark A. When you see the from, that means this from. This means where you'll start from when you're trying to work it out. So if we draw this, so I'm going to like put A here. And remember, when we do these compass bearings, it's good to put a little compass in. So I've put a little compass in, that's A. And I'm going to work out the next. Now it says B, so B, from A, B is 105. So if you think about it, this is 90. So 105 will be out here. So we go out there, and there is B. Put a little compass on it, write B. And it might be helpful to just pop in some information. So you know that that is 105, okay? So if this is 90, I can tell in there is 15. Can you see that? Yeah. All right, so if I know that's 15, you know this little bit in there is 15. Just might be handy to make sure you're putting those bits in. All right, let's do the next part of what they say. Now they say the landmark B from the lookout tower. So now they want the lookout tower is 142. So we can see roughly that the tower is up here. So we're gonna we know it's sort of north, so we'll put it up there. Put a little compass. Here is, now this is actually, because we're talking about the ground, it's like the bottom of the tower. Yeah, we're talking about just if we were looking down on the map. So I'll call it BT. Now it says from that tower, B is 142. So maybe a little bit off here. I'm going to move my I'll move my tower over. I'm going to move my T a bit over so I can get that 142. Doesn't matter. All right, so we'll do this. This is the bottom of the tower. And if you join them up, okay, what they're saying is that this is 142. Okay, so if I know that's 142, you can find out a few things. So what's 180 minus 42? 142. So you've got, good, so you know a few things in here. You know that that's 38 in there, and this also in here makes that one 38 degrees. All right, just popping those things in there. So when I do that, I can also see now I've got like a right angle triangle, 90 degrees in there. So what's 90 degrees minus the 38 plus the 15? Let's do that on the calc. So can we see I'm finding out that this is 37 in there. Yeah? Is everyone okay with that?
Yeah.
Okay. I'm going to, now, they said, let's look at what the question's asking me. The question wants the direct distance along the ground, so this would be on our map, between A and B. So, pretty much, this is the question, yeah? There's the question, that's what we want to know, that bit there. Landmark AB is along there. So, what I'm going to have to do is use this triangle. So you can see, if I'm just going to separate this triangle a little bit, and I'm just going to draw it like this, and so this is BT, this is A, this is B. Okay, I'll call this X, that's the question. I know this is 37. Now look up, obviously we need a few things. We need to find, say, the distance between A and BT, so I'll call that Y. Up here, I have a line between A and BT up there, so I'll call that Y up there, yeah? And I also need to know between BT and B, which is Z. I can find that using that triangle here, all right? It is a hard question, boys. So don't stress too much, but we're going to get through it. So up here, this is a right angle triangle. I can use Pythag to find this Y, okay? So I'm going to say 170 squared equals 80 squared plus Y squared. And you can always use your solve, comma Y, and we'll find out what Y equals there. And we can do it here for the Z2. 234 squared equals 80 squared plus Z squared. And we'll solve we'll do solve, comma Z, and we'll find out what Z equals. All right, so let's just do. Okay, so we get this one to be 220 and this is 150. Because you've found them out, you can pop these on this diagram now. We've got Z is 220 and Y is 150. So, and this green X here is the question, like the final question. So now what I'm going to do is use this triangle to solve it. So I'm just, because I'm running out of room, I'm copying it and I'm going to put it on the other page. Okay, so we've got it down to this and we need to know X. So now I've got a few things. So when I've got this, I'm probably need to get some more angles. So I'm going to use maybe, and because this one, I need this angle in particular because I need it for there. But what I'm going to do is I'll find this one. I've got to call it a different letter. I'll just call it P. I'm going to find P and I'm going to use the sine rule. So if you remember the sine rule, I've got both of the B's, so I'm going to use 150 over sine 37 equals, and because I've got this side, that's the one I'm going to use. So I'm going to use 220 over sine, and I'm going to try and find P. Now, if you remember back to our notes, and when we're doing this, when we do solve, remember you're going to do comma P, but remember I want you to put that line, and we need to write that P is going to be in between that. So we do that on our solve. We need to do that when we use the sine rule. So we pop this into our calculator, and we'll end up with P equals 62. So we know that this is 62 degrees. So what I'm going to do is I'm going to work out that this must be 180 minus the other two added together. So 37 plus 62. So I end up with, this one is 81. So why did I do that? Because I'm going to have to use the sine rule again so that I can find this X. So I'm going to go X over sine 81 because that's the angle that goes with that one. And then I'll still use the 150 over sine 37. So once again, you'll do the solve comma x. Make sure you do that line x 180. Actually, you don't need to do this because it's the angle. It's the distance. So you work that in, and hopefully what we get is x equals 246. And if I go back, okay, so we end up with, we find the answer, and we got it to be C, okay, 246, just to show you there.